I don't know if there was a miscommunication with the speakers on the timing. We're a bit ahead. Pepe started out going way too fast, but Joseph, he was a gentleman here. He said, "Well, just give me the last 3 hours and I'll do it myself." So we're going to hear about why power consumption matters. And you ready?
I'm ready. Thank you. Yes, I'm going to stretch the meaning of the word lightning talk, but it probably will be fast. I'm going to try to keep it within the time allotted. Before we get started, I just want to point out the slides are available at our GitLab repository at invent.kde.org/team/eco/BE for FOSS. That stands for Blaue Engel for FOSS. There's many references in here if you want to look it up afterwards. You're welcome to check out this and other presentations. This is going to be maybe a slightly different talk than all the other talks today and tomorrow, in that that's the only repository that's going to be presented on the screen, and there's going to be no code. I'm going to present today about something that probably all of you are already thinking about in terms of optimization and performance, but I'm going to present it with a different framing in terms of energy consumption. And I hope to convince you that energy consumption of digitization does matter, and present to you how to eco-certify your software. And maybe you already have a hint, at least for the people who live in Germany or grew up in Germany, to answer this question. Who here knows what paper products and software have in common? The Blue Angel. So the Blue Angel is the official eco-label of the German government, and they eco-certify paper products. That's what they're most well known for in Germany. And now, as of 2020, they also eco-certify software. Before we get started with the Blue Angel, though, the Association for Computing Machinery, it's one of the oldest associations of its kind, also one of the largest, started in 1947, released a report in October 2021, where they estimate that the ICT sector contributes between 1.8 and 2.8% of global greenhouse gas emissions. That includes, that's a very complete picture that includes things like production, transportation of devices, blockchain and proof of work systems and things like this, as well as internet usage and whatnot. As a point of comparison, the global aviation industry is estimated to contribute about 2.5%. Okay, so we're roughly at the same numbers as the airline industry. Another way to look at this data is what is contributing to the energy consumption. Now, this is from a different report. This is from the Shift project. It's a nonprofit in France that is aiming to move and shift away from fossil fuels. This is a distribution of the energy consumption of production on the top right here, and usage in digitization. This is from 2017, so the data probably looks a little different today, especially after the pandemic shifted some of our behavior. This does not include things like transportation, end-of-life treatment of devices. It doesn't include blockchain, things like this, but it still provides a nice framing for what we're going to talk about. As you can see, production is about 45% in their estimate of the energy consumption, and usage is about 55%. I'm sorry, not about, it's exactly 55% in these charts. I'm not going to talk today about data center usage or network usage. I am going to talk about things related to production and the energy consumption there, in particular in terms of conservation, and terminals, which is for end-user devices, in terms of efficiency. So the two main ways that I'm going to frame energy consumption here is in terms of the efficiency, that is achieving the same result, doing the same task, but requiring less demands on your hardware, as well as energy conservation, eliminating or avoiding unnecessary processes. This is from a report from the German Environment Agency, in which they compared various software products doing the exact same thing in terms of how much energy it consumes. On the y-axis, you have watt hours, and then the various plots represent different software products. I'm only going to focus here on the far left two bars. These are two word processors, again, doing the exact same thing. Word processor 1 consumes about 4 times the energy as word processor 2. For one individual user, this might be insignificant, but when you think about how many word processors, how many people use word processors every day in every office and every university around the globe, this can add up very quickly. And to illustrate that point, I want to present a back-of-the-envelope calculation. This is taken from an online course Detlev Toms gives at the Hasso-Plattner Institute. If you imagine eliminating 1 CPU second from a process for one worker over a year. So 1 CPU second is estimated to be about 10 watt seconds in power. If a worker has 20 such transactions a day that has 1 less CPU second, over 230 workdays in a year, that is the equivalent to about 46,000 watt seconds. That's not very much. That's about a 50-watt light bulb on for 15 minutes. Now, if you think about that multiplied across the population of the EU, so I'm going to imagine here, so EU has about 500 million people. Imagine here 2%, that's the estimate of the market share for GNU Linux. And I'm using the example here from KDE. About a fourth of them use the PDF reader, Okular. This is just numbers I made up for the calculations. I don't know what the exact number is of how many people use Okular. That would be the equivalent to about 2.5 million users. And with that 1 CPU second reduction in the process, we're talking about 32 megawatt hour savings for the EU. That's the equivalent to driving back and forth with an electric vehicle from Paris to Beijing 11 times. Okay, so these numbers add up very quickly. If I can convince 300 Qt contributors to achieve 10 of those optimizations, we're talking about 96,000 megawatt hour savings, and that's roughly the equivalent to the power consumption of 30,000 two-person households, so a small city, in a year. So that's the first part, talking about efficiency, and I'll come back to that in just a minute. Now, thinking about conservation. This is, again, from a study looking at 2 word processors, comparing them when doing the exact same thing. Word processor 1 compared to word processor 2. I'm not going to look at what's happening before this red line here, but to point out the x-axis is time in milliseconds and the y-axis is power in watts. So at this point, at the red line, the text editor saves the document. So there's a little bump here when it saves, writes to disk, and then goes idle. For word processor 1. For word processor 2, the exact same thing is happening, but it doesn't go idle. It continues doing things. What is it doing? We don't know. Could it be telemetry? Is it phoning home, giving some statistics to the developers? Can the user decide to turn this off? Is it necessary for the functionality of that software? That's the first way I want to talk about conservation. I'll come back to that in just a minute. Another way is thinking about software-driven hardware obsolescence. Some of you who may have family or friends who want to update their laptop might get a warning that their device doesn't meet the minimum system requirements for the newest operating system that they want to install. Or the device is no longer supported, right? And you have a couple of options here. You can run an out-of-date operating system or software product, which of course has all the security issues, which I know several people who choose to do because they don't want to buy a new device. You could switch to GNU Linux. This is what I often try to convince people to do in this situation. Or you can buy a new piece of hardware. Well, if you buy a new piece of hardware, you're producing and shipping hardware unnecessarily because you still have a functioning device. It's just the software doesn't run on it anymore, right? And those functioning devices end up being discarded as e-waste. This is a statue some of you may know. It's the WEEE statue, the Waste Electrical and Electronic Equipment statue. It represents the devices discarded from an average UK citizen's in their lifetime. It weighs something like 7 tons, it's 7 meters tall and weighs about 3 tons. Okay? It's a lot of waste over one person's lifetime. And one of the core messages that I want to, so I work for the KDE Eco project. Our website is eco.kde.org. We're a free and open source software developing community. And one of the main takeaway messages I want to have today is that the 2 pillars of free and open source software, that is transparency and user autonomy, already put free and open source software at the forefront of sustainable software design. And it's not just me saying that. At the end of the talk, I'm going to come back to the Blaue Engel eco certification, where they recognize these values as being important for sustainable software. Okay? And let's think about what that means. So coming back to that first comparison of 2 word processors, making energy consumption transparent, so extending the idea of transparency, which is already a part of open source, to how much energy does our software consume, gives us an opportunity to first know how much it consumes and then drive down the energy consumption without having to be dependent on companies to do this for us. As users, if we know how much energy it consumes, we can decide which products we want to use for what we needed to do it for. So if I'm choosing between 2 text editors and this is how much they consume to do the same thing, I might choose the more efficient text editor for my purposes. If we come back to the when you scale that up, so I rephrase it in terms of acting locally within the EU, with the example that ended up with a 30,000 2-person household energy consumption. We used to say, act local, think global. Well, with software, you can act local and act global. Software is used and distributed around the globe. So changes that you make that have an effect within the context of the EU, if you think about it globally, you have 16 times that in energy savings. In the example here, that would be like the equivalent to the city of Liverpool annual consumption in a year. So you can have really big savings once you scale it up. And we can push a global conversation about the energy consumption of software that we're using. When it comes to potentially unnecessary processes here, as developers, we can decide to give users choice. For example, at KDE, you have an opt-in policy for telemetry. We do have telemetry, but it's off by default. That's going to save all that energy that's being used for the users that don't want it. As developers, you can give software users that option. In the free and open source community, we can also influence the software design of the software we're using, unlike with proprietary software. When it comes to software-driven hardware obsolescence, many of you may know this, you can run Debian on pretty much any device. You can keep old hardware in use, and by continuing to give up-to-date software, devices don't end up being discarded, and they don't have to be produced unnecessarily and put into landfills. And these, we can demand more. So right now, the FSFE, the Free Software Foundation Europe, has an open letter to legislators to demand that users can install any software on any device. The right to repair should go beyond just the hardware level. It should also be extended to the software level so that we can keep devices from being discarded when they still work. And perhaps I'm not very good at graphic design. Perhaps we can shrink that Wii statue, make it much smaller. So this now brings me to the second part, which is the Blue Angel eco-certification. The award criteria recognizes transparency and user autonomy as being crucial to sustainability. They released the award criteria in 2020, and that was the inspiration for the 2 KDE Eco projects, the Free and Open Source Energy Efficiency project, and the Blaue Engel for FOSS project, for which I'm the community manager. There are 3 main categories to the Blue Angel Eco certification award criteria, what I'm calling the ABCs of the award criteria. The first 2 categories, potential hardware operating life, that you can run software on on hardware that's at least 5 years old, as well as the user autonomy aspects. Can you uninstall the software? Can you run the software offline or without advertising, reducing the unnecessary processes? These are criteria that free and open source software takes as a given. We are already fulfilling many of these criteria, so there's not much that we need to do there. We have a huge advantage in this area. The category that needs some extra work put into it is making the energy consumption demands transparent. And that's going to be summed up here in 3 steps: measure, analyze, and certify. How do you measure software? This is specific for the Blue Angel certification. It's one method. There are many methods that you can use. You set up a lab. Jumping ahead. Where you have a system under a test running the software you want to measure. That's connected to a power meter, and both of those are then the data is then aggregated on a second computer. We set up a community lab for free and open source software developers at KDAB. They were very generous to give us a space in their offices here in Berlin. They also offered us lunch, and you can see a bunch of smiling faces here. It was a really nice afternoon. We spent about 10 hours or so coming together and working on setting up this lab so that we can provide the community an opportunity to measure their software and make their energy consumption transparent and hopefully drive it down. What do you measure? You measure 3 things. You have a baseline measurement, the operating system, the idle mode measurement, which is the application while it should be idle, or while it's idle, and the standard usage scenario, which is a usage of that software representing the typical user when they're doing something. For example, the text editor, opening a file, writing some text, saving it, searching through it, things like this. You take the results, you analyze it. There's a tool that's been developed by the Umweltcampus Birkenfeld called OSCAR, the Open Source Software Consumption Analysis in R. It's an online tool. It's free and open source. You can also download it and run it on your computer, in which you need a log file of actions, energy consumption, and hardware performance data. You put it in there. It feeds back a report. This is from Kmail, the email client. This is showing 30 repetitions of the usage scenario script. And you can see here, for example, again, this is time on the x-axis and power on the y-axis. You can see, for example, when sending an email with an attachment, it consumes energy, right? That's what you'd expect. With this report, you get the documentation in order. You have your transparent consumption demands, and you submit them, and that's reviewed by an independent party. And we did this for the PDF reader Ocular, and KDE is very proud to say that we are the first ever eco-certified computer program. With Ocular, it's the first both for the Blaue Engel as well as for the Global Eco-Labeling Network, which is a network of 30 eco-labels representing about 60 countries. So this was in February, and we hope to have the awards ceremony soon with handshaking with politicians and a party afterwards. And so I'll leave this with, will you join us in making your software, the energy consumption transparent, and then working on efficiency, and hopefully making a sustainable digital future for us and for future generations. So there are many ways to get involved if you're interested. So thank you.